What is up, everybody? Welcome to an overview of how to write the formulas of ionic compounds from their names. Now, I'd like to point out first, we are dealing with ionic compounds, which are compounds that contain ions or charged particles, and they usually have a metal or a polyatomic ion in their formula. So you have a metal element with either a non-metal metalloid or polyatomic ion, or you have a polyatomic ion with a non-metal, or you have two polyatomic ions. Anyway, tips for writing formula, it's pretty easy. I'm going to break it down to 3 simple steps on the next slide. But really, what you need to know is that the element or the polyatomic ion that has the positive charge is called a cation. All right, because cats are cute little furry creatures that bring positive vibes to people. All right, another fancy name for a charge is an oxidation number. So if you look on a periodic table and it gives you all these pluses and minuses and say the top right corner of each elemental box and calls those oxidation numbers, you can treat that as the fancy chemistry way of saying charge. Yes, it's not the exact same, but it works close enough for what you're probably watching this video for. Right? And then the element with the negative charge goes second. And an element with a negative charge is called an anion. All right, kind of like ants. They come and they ruin your picnic, which makes it a negative day. So you got your cations are positive, your anions are negative. All right, and in your compound, you're going to see that the sum of the charges has to equal 0. Or, that's for a compound, or the charge of a particle if you're dealing with adding up all the charges on an ion. That's a little bit more rare. We're not going to see that in any of today's examples. That's a little bit farther beyond what we're talking about right now. But, you could just see that it is true. So, for the most part, we're going to be just trying to make sure our compounds, all the charges equal 0. Polyatomic ions go in parentheses, especially if there's more than one. All right. For me, if you're watching this because I am your actual teacher, I'll let you always write them in the parentheses, even if there's a 1 there, just to kind of get used to seeing them together. It's not the textbook perfect way to write it. If you did that in a scientific journal or something, it would probably get caught by the editor, or, maybe you'd get picked on a little bit for it. But if you get to that level of chemistry, you'll have weaned yourself out of this habit of writing the parentheses. I just find that, like, early on in an intro to chem, general chem class like this, it's good to just always write the parentheses. So for me, you can always write them. If you have a different teacher who's having you watch this video and it's not me, then you might want to ask them. So what you need to do is you need to remember that a lot of times we have metals as the first symbol. All right. Once in a while, you will get a polyatomic ion. And 99% of the time, that polyatomic ion's name is ammonium. All right, ammonium is the most common polyatomic ion that we see at this level of chemistry. It has a symbol of a nitrogen and 4 hydrogens together with a positive charge. All right, and you may see it in parentheses, you may not see it in parentheses, but that would be the full first symbol if you see this word ammonium. All right, so how do we write these things? Let's actually dive in a little deeper and kind of see what we're talking about and how we're talking about them, how to write these symbols. And it can be easily broken down to 3 simple steps. All right, the first step is you write the symbol and the positive charge, the oxidation number, if you will, of the first word in the name. Now, some elements have multiple positive charges. There will be a Roman numeral telling you what the charge is. All right, and Roman numerals have a 1 line equals 1, 2 lines, 2 lines would equal 2, 3 lines equals 3, an I and a V equals 4. Just a V equals 5, a V and an I equals 6, and then a V and 2 I's. I actually got to write the 2 I's, so I'm going to talk about the 2 I's. A V and 2 I's equals 7. All right, so if you see one of these Roman numerals, they tell you what the charge is. If you see a Roman numeral of 1, it's plus 1. Roman numeral of 5, the charge is plus 5. So you write your symbol and the positive charge. Now, if there's no Roman numeral, you can find your charge on the periodic table, and that should be really easy to go to from there. The next thing is you write the symbol and charge of the negative, or the symbol and the negative charge of the second word. Now, there's a couple differences here. If the word ends in "ide," more likely than not, you have an element from the periodic table that has taken on a negative charge, and so the ending has been changed. So if you see the word chloride, you can see the element chlorine is very similar. It's just the "ine" at the end of chlorine got changed to "ide." Same is true in oxide. Oxide comes from oxygen. So you kind of need to look out for that. All right, you look those out, and that tells you "ide" most of the time refers to some type of element from the front side of from the periodic table itself. If you see something that ends in "ate" or "ite," you gotta look on the back of the periodic table, because "ates" and "ites," these are polyatomic ions. All right, "ates" and "ites" are polyatomic ions. You got to kind of keep that in mind. Remember, keep the parentheses. Again, for students specifically in my class, you have a list of polyatomic ions on the very back of your periodic table. If you're taking a New York State Regents chemistry class, there's a table of polyatomic ions in your reference tables. All right, and you got to just know most of those end in either "ate," 8, or "ite," ite. And so "ate" and "ite" lead you to these polyatomic ions. The last part is to crisscross the numbers from the charges. ignore the signs, and then you would reduce the numbers and rewrite the formula. All right, and that's how you do it. Now, we're going to see these 3 steps in action on the next couple of slides. So I'll point those out to you there, and it should hopefully be a little easier to understand. So here's our first list of examples. All right, you can see up in the corner here, I've kept those 3 steps for you, although I got rid of like all the little extra stuff. And then I have a periodic table for you right here. All right, it might be a little hard to see, but you hopefully have yours in front of you or can get one. And then over here is your list of common polyatomic ions. Alrighty. So, what we've got going on is we can go in and let's start by doing this first one. We got aluminum oxide. So the first thing is aluminum is my first word. Aluminum is a metal, and that metal exists right here on the periodic table. It's Al, and if I was to go and zoom in, well, that's not what I want to do, but it works. You can see the Al has a +3 oxidation state, oxidation number. So our Al has that +3 charge to start with. So I take this, I go Al, and it is +3. All right, I'm going to do step 2 in blue because the yellow won't show up on the white background so well. And my second word is oxide. Now, we said earlier oxide comes from oxygen. If I, again, zoom in here, here is oxygen. It has a -2 charge because oxygen's mostly -2. There are times when it can be something else, but based on the table that I use and that you guys probably have in front of you, oxygen has a charge of -2. So we're going to go back. That's not really how I wanted to go back. There we go. Oxide, we said, is oxygen, which is an O, has a -2 charge. The last thing is we just crisscross the numbers. We don't worry about the signs. We take this 3 from the Al. It comes down to the bottom of the oxygen, becomes a subscript of oxygen. The 2 from the oxygen comes down, becomes the subscript of aluminum. And then when we rewrite it, we get Al2O3. And that ends up being our answer. All right, let's see how this works. This means we have 2 Als. It means 2 +3s, which would be +6. We have 3 oxygens, which means there's 3 -2s, which is -6. A +6 and a -6 equals 0. So the charges all cancel each other out. The crisscross helps us cancel those charges out. So remember, you're just taking the number from the positive, it becomes the subscript of the second symbol. The number from the negative becomes the subscript of the first symbol. Let's look at another one. We got sodium nitrate. All right, sodium is right here. It's Na. It has a +1 charge. We'll do that up in red. Sodium, Na +1. My second word is nitrate. Notice it ends in ATE. Means it's a polyatomic ion. All right, so I need to go to my polyatomic ion charts. Here's nitrate is NO3 in parentheses with a -1. So I'm going to go back and nitrate becomes NO3 with a -1 charge, or 1 minus. Now I crisscross the ones. The 1 from the sodium comes to the outside of the parentheses, meaning there's 1 NO3. The 1 from the NO3 comes down to the sodium. There's 1 sodium. I get NaNO3. As I said, I like to keep the parentheses so we can see that it stays together. But you could also just write it NaNO3, and it's the same exact thing. It's just good to keep the parentheses because sometimes you need to show that there's more than one of everything in the parentheses. We'll see that example in a little bit. All right, our third one, we got calcium. Calcium is right here on the periodic table. It's a Ca. It's got a little +2 charge in its box. So we're going to start with Ca +2. Second word is oxalate. Again, ATE. So I got to go find it on my table of polyatomic ions, and here it is. All right, just circled it there in blue. Zoom in a little bit. It is C2O4 with a -2 charge. All right, C2O4 -2. So I'm going to go in parentheses, write my C2O4. That -2 is the charge. Crisscross the numbers. The 2 comes to the outside of the parentheses. The other 2 goes down to the calcium. But notice they're both 2, and part of step 3 is to reduce if possible. Well, 2 and 2 reduce each other down to 1. So I just get Ca C2O4. All right. And like I said, I like to keep it in the parentheses like that. All right, we got 3 more examples. Okay, here are the last 3 examples. Very first one, we're starting off here with something called ammonium. Now I can look all over my periodic table. There is no ammonium. That's because ammonium is right here on my polyatomic ion chart. It's the second one down. It has an NH4 in parentheses with a +1 charge. My second word is sulfate. Again, it ends in 8, which means it is also a polyatomic ion. I'm going to go over here. Near the bottom of my ion chart is sulfate. SO4 -2. SO4 -2. That 1 comes down for the SO4s. The 2 comes down on the outside of the NH4, 4's in parentheses. So I get NH4 is in parentheses with a little 2. That means I have 2 of everything in the parentheses. I have 2 NH4s. And I just have the 1 SO4. And that gives us ammonium sulfate. The last 2 examples are very similar. In both cases, we have iron. Iron is element Fe. If we look on the periodic table at iron, at Fe, it has 2 charges, a +2 and a +3. This 2 means that it's plus 2. This 3 means that it's iron plus 3. That's how those Roman numerals work. How whatever number the Roman numerals is telling you is the positive charge. Both of them are carbonate, which means they end in ATE, 8. If I look at my table of polyatomic ions, there's carbonate right there. All right, CO3 in parentheses minus 2. So I write down CO3 in parentheses with a minus 2 for both of these. And now here's where these two compounds differ. In number 5, in iron 2 carbonate, the 2's cancel each other out. So I just get FeCO3 in parentheses. In iron 3 carbonate, the 2 and the 3 don't cancel out. The 3 comes down for the carbonate. The 2 comes down for the iron. I get Fe2CO3. That CO3 is in parentheses. And a 3 comes down there. And that's how I get that one. And those are the 3 steps to writing an ionic compound. All right? The best way to get good at it is to practice. You can just search the Googles for writing ionic compounds worksheet, and you'll find a bunch of things you can practice. Or your teacher, if they're showing you this, probably assigned you some kind of homework. You can do that. Chemistry books all have this in there. Usually in the ionic bonding chapter is where you will find it. And use the index or the table of contents to find that stuff. All right, and really give some practice ones a shot, and if you're having trouble, contact your teacher, whoever that person may be. Alrighty, thank you, and have a glorious night or day.